We lived in the level of poverty that can only be imagined. I remember going to the store once with the last 50 cents we had in the house that month. So we'd always buy day-old bread, and it cost $0.25. Regular bread was 50 cents, and there was only one loaf of bread. And I went to the counter and I asked the woman if there happened to be any other bread. And she picked up a fresh loaf of bread and brought it back, and she said, "This is close enough." Those types of things imprinted on my life. We use about 40 seconds of ambient listening, conversational speech. We could analyze the health, including progressive neurological diseases, cognitive health, behavioral health, and you're doing it with one of the most natural data sets we have, which is speaking. And voice and the creation of speech is the most complex motor function we have in the body. It's connected to so many things. It's self-conscious, so it makes the data objective. Healthcare should be available, regardless of where they're born.
Hello and welcome to the Uprising Show. And today I have a very special guest with me, Henry. Welcome to the Uprising Show.
Thank you so much. It's excellent and wonderful to be here with you.
Henry, I'll let you take a minute to just give a brief introduction about yourself to the audiences, and then we will go into more conversation, more deep questions afterwards.
Thank you very much. I appreciate it. I'm Henry O'Connell. I am the CEO and co-founder of Canary Speech. And Jeff Adams and I founded Canary Speech approximately 9 years ago. And we met 40 years ago. At the time, I was at the NIH doing research in neurological diseases, and Jeff was at the NSA building mathematical models to de-encrypt spy messages. We were friends from there forward and started the company in a bagel shop 9 years ago.
Very fascinating. Well, we'll talk about the company, but before that, let's go back in time. Where were you born and raised, and what early influences shaped your, trajectory towards the world of healthcare?
So I was born in Connecticut. I was actually born in Hartford, Connecticut on Zion Street, opposite Trinity College. We lived in a 6-apartment complex owned by one of our cousins. And when I was in second grade, my parents had saved up enough money. My father was a World War II vet. My mom worked in Pratt & Whitney as building parts to support aircraft during World War II. And so I was born in 1953. And we moved from Hartford to Wethersfield, a suburb. My parents did that because they thought, and they may have been true, that the school system there was a better one to raise their children in. Approximately 4 years later, my father passed away, and my mom had 5 children. And at the time, she had her father also living there, my grandfather, which was just a godsend for me personally. He had suffered a major heart attack, and my mother was caring for her father, along with 5 children in her home. And it was pretty much all hands on deck. We lived in the level of poverty that can only be imagined. I mean, we did not finish a month with food in the house, ever. But the local dentist supported us. The local doctor made home visits at the time. Even a clothing, house-to-house clothing person would come every year and just lay out clothes for the start of the next year. And he'd always finish it by saying, "Mrs. O'Connell, you don't worry about this. Your kids need to be clothed." And so we had a lot of help along the way. I remember going to the store once with the last 50 cents we had in the house that month. And we were all working jobs and just we stayed in the home. We paid the mortgage. We were able to do it. But I went to the store because we'd always buy day-old bread, and it cost $0.25 at the time. regular bread was 50 cents. And there was only one loaf of day-old bread. And I went to the counter and I asked the woman if there happened to be any other bread. And I was there regularly. She knew of my circumstances. And she walked over to the bread aisle and she picked up a fresh loaf of bread and brought it back. And she said, "This is close enough," and took my 50 cents for 2 loaves of bread. Those types of things imprinted on my life. And as our life continued, I was lucky enough to get to college, to go to graduate school. And all the way along the way, people were sensitive to the needs of families that were in need. And that helped focus what we're doing today. And when we talk about the company, you'll understand that when Jeff and I decided to do this, we were advanced in our careers. He had just finished up building the Amazon Echo with a team that he led. I had been doing corporate turnarounds. So I asked him then in that bagel shop, what do you have left on your table? What haven't you done that we ought to do before we're finished? And he said, well, I've always wanted to apply speech and language to the analysis of human condition and disease. I said, okay, why don't we do that?
Wow. This is, thanks for sharing even your journey. And I do want to take an opportunity here to the people who help you through those times, the help that you got. And it's just so much impact people have on people's life. We don't realize that. And when I have these conversations with people, this is one of the things that comes up, and I make it almost an intentional effort to just take a pause and give a shout out to all the people who helped you through those times, you and your family, and made sure. And that's what keeps us human. That's what keeps us, keeps the things moving forward. It distills that kind of same things that now you're doing probably in your mission. So it's that important. So, like I said, everyone who did for you and your family, big shout out to them. And now to your story with how you met with Jeff and that bagel shop is, let's talk about this a little bit. So, obviously, you've led global companies by then across life sciences, diagnostics, healthcare tech. But then Canary Speech feels different, more personal. It seems like more mission driven. Can you go a little bit? What inspired you to take this specific leap?
Yeah, absolutely. As I mentioned, we were in the bagel shop, and Jeff had actually been in speech and language since the NSA. He'd been instrumental in developing some of the key technologies in speech. For 25 years, natural language processing had been a tool that many institutions, very, very bright people, tried to apply to the analysis of different diseases with mixed success, but no commercial products. NLP is not based on what words we speak. It's based on how words are created. And in that meeting in the bagel shop, although I was a novice, in talking to him, I certainly understood that. And he described to me where the field was. And I said, let me relate a question. He knows my family well. And I said, when my daughter gets home, at the time, she had already graduated from college and was married and had a child. But I said, when she was in high school and she would come home from school and walk in the house and she'd go across the room after soccer practice, football. I knew whether it was a good day or a bad day just from how she was walking, from her gait. When she turned and looked at me, I got all kinds of information. And when I said to her, how's your day going? Or how was your day? Any parent knows what the answer was. It was fine. Thank you. And walk away. And I'd always say, no, time out. Come back here. And we'd go through it a little bit, and maybe it was algebra, maybe it was chemistry, maybe it was a soccer coach, who knows, And I said to Jeff, I said, Caitlin's married now, and she's out of the house, and she has her first child. And she's working a wonderful job with 3M Medical at the time. And I don't get to talk to her like I did when she was here and see her like I did when she was here. But I'll admit I call her twice a week. No, the truth is probably more than that. But I said, every time I call her, and it has nothing to do with the words she's speaking, and I don't have any of the physical cues anymore, Jeff. I can't see her gait. I can't see her face. I can't see her body language. But I know within moments whether it's a good day or a bad day. I know if she's stressed or she's anxious or she's upset or she's happy or she's excited. I know all those things. And I can't see any of these clues anymore. And it doesn't have anything to do with words that she's using. How am I doing that? And he said, I'm not sure. And I said, because that's what clinical people do every time they sit with a patient. And they're good at it. And if we could create a tool, an objective tool that sits in their toolbox that validates their, what we call intuition. It's really their expertise, their training, their experience, their knowledge. It's all those things. And it combines in milliseconds of time to give them an understanding of the patient, irrespective of what the patient is saying, and it guides them to the next question. It is what medicine is. It's the personal element of medicine. If we could give them an objective tool that supports that, maybe even helps train in that skill set, and does that in real time. If we could do that, that would be amazing. And so that was the start of Canary Speech. We decided we would be in a clinical toolbox from the very start. And as being that, we're a partner with medicine. We're a partner with hospitals. We're a partner with a patient. So we respect that, and we built our company in those terms. That's how we got
this. So once, I guess the follow-up question is you mentioned the word toolbox, right? So it's obviously very intentional how you said it. So can you expand that a little bit? Why specifically you're saying a toolbox, and then a little bit explain exactly how it works, and what are a few applications that you're already seen it with your clients or user base right now?
Sure. The wonderful thing about working in the industry we work in is, and I often think about this, our oldest son is a doctor. He made the decision on the track between PhD and MD a year after he graduated. He's waiting for a young lady, now his wife, to finish up, who was a year behind him. Gave him a chance to think a little bit. He had done some research in neurology and neurological area. But he eventually decided to go to medical school. And his decision was very similar to those of virtually everybody in healthcare. It can be a stable job, but it's not the easiest one on the planet Earth. You're dealing with difficult times in people's lives. You're dealing with stressful situations. You know that before you go in, but you decide to go in anyway. You develop a level of expertise in the field that very few people ever achieve. Your knowledge, your experience, your empathy, all of those things play into your ability to be good at what you do. When I speak about a toolbox, I talk about, similar to what Microsoft talks about, a co-pilot. The pilot is the one flying the plane. Ultimately, they're making the decision. The co-pilot is there to support those decisions. We're actually a clinical decision support tool. We're in the toolbox. They can pick that tool up. They can use it anytime they want. They can do it passively. We operate in the background with an informed consent in the same high trust environment they're operating in. All of those things are true. It makes us a good partner. It's a requirement to be there. But we use ambient listening. So we don't have to ask the patient, go do this and come back and show the results. We're providing everything by listening just to the conversation between the clinical team member and the patient. So in that sense, they could pick up any tool they need to in order to make the informed decision about the diagnosis. But The diagnosis is in their hands. It's not just based on what they're learning right now. It's based on everything they have learned in the last 15 years. Their training, their experience, their exposure to different types of patients, their conversations with their colleagues. They can draw a colleague in at any time and get an opinion. All of those things, if you can augment the accuracy of that, you can inherently improve healthcare. And it's a force multiplier for those individuals. It extends their reach, if you will. And if you could do that, regardless of where a person is in the world, regardless of what language they're speaking, provide objective information towards the decision about a person's healthcare, that could be a very nice tool to have.
So is this primarily focused on just the biomarker side, or is there more data that comes in that helps in that decision making? Could you expand on that as well too?
Sure. Our primary focus is on 2,548 features in speech. We look at those every 25 milliseconds, but with a 10 millisecond slide, functionally, it's a 10 millisecond window. So we're gathering 15 plus million data elements every minute. We usually use about 40 seconds of ambient listening, conversational speech. We don't ask people to say anything. We don't have a script. We don't just listen to them talk like you and I are talking. We could analyze the health of both individuals across any one or all of the models that we have built, all the algorithms, including progressive neurological diseases, cognitive health, behavioral health. We're currently working on PTSD and on MS to add to those, Huntington's and Parkinson's and others. We're going to add this year our first childhood illnesses, ADHD and autism, along with behavioral health for children. But we very seldom use anything but the vocal biomarkers. We are capable of doing what is considered multimodal analysis or multimodal algorithm building. And for models where the accuracy, we want higher accuracy, we can draw in other elements. For MCI, for instance, we can draw in other characteristics of the individuals that help us improve accuracy in the models.
And what is the science, or what is how does the AI or ML system actually analyzes the speech to produce those insights? Can you about that too? Is it exactly how that engine works?
Sure. So for every disease, and we validate in every language that we deploy in, for every disease, we develop an algorithm in concert or in partnership with a healthcare institution, Harvard, Beth Israel, Hackensack Meridian, Intermountain Healthcare, Ulster Hospital in Belfast, the National Institutes of Health in Osaka, Japan, all across different places. We currently have 13 ongoing developments with different institutions around the world and different languages. We use the clinical expertise, the diagnostic capabilities of a specialized clinical team to diagnose a particular disease. Along that path, we also are collecting audio. We're collecting the audio between the patient and the doctor. We take that audio now with the label that the doctor gave us, and we build using some proprietary software and proprietary approach. We build an algorithm that correlates to the doctor's diagnosis. And that correlation we have tested across populations, and its accuracy is maintained across broad populations. So the next person in the door, we don't need a sample or a diagnosis of the individual. We can analyze an individual. Now we have about 12 active commercial models. From the 40 seconds that we capture, as I mentioned earlier, we could measure any disease or all of them at the same time and return scores in real time to a tablet or to a smart device for all 12 of them, or for a designated 2. And for behavioral health and cognitive health, as a clinical decision support tool, it also receives a CPT code, insurance reimbursement. So the hospital using our product receives reimbursement. And if we integrate that product as we are into Dragon Copilot, where when they're doing the dictation of notes for patient and doctor, they're using the patient and doctor audio. We're listening to the audio of the patient. And in real time, we're telling the doctor where their behavior, their anxiety, depression levels are, whether they have MCI, mild cognitive impairment, or Alzheimer's disease. So we're doing that in real time. And then the hospital can actually submit for reimbursement for that from insurance.
I am a little blown away with how this works, because to me it seems like, wow, like, that's my reaction to this. Like, wow, like why we don't know much about it, right? That's kind of how I felt for 1 second. And but then is this is does this apply? This 40-second is it for a certain segment? Is it more like to early detection, or is it more preventative, or like anyone? Is this for anyone? Can be, that analysis can be done for any conversation? Give us a little bit insight on that.
So generally, we build the models for early stage. So first recognition that a person has MCI, mild cognitive impairment. The transition in Huntington's disease, there is what is called a pre-manifest to manifest stage. It's a dominant gene, so they are going to get Huntington's, but when they get Huntington's, and that's documented, they can start treatment, which is reimbursable by insurance. We're 98% accurate in identifying the first time that ever happens while the doctor's talking with the patient, while the neurologist is in discussion. We're used in primary care in annual screenings for anxiety and depression. So instead of going to the side and doing a GAD-7 and a PHQ-9, which you have to do, and it's subjective and you're answering 7 questions or 9 questions, and then the doctor gets a report on that. If they can get it while you're still there, that's great. Instead of doing that, while the doctor is actually just in conversation with the patient, we tell them what the anxiety and depression levels are. And so we don't need 40 seconds continuously either. It could be 10 seconds here and 8 seconds there and 4 seconds here and 12 seconds there. And we're intelligent enough to know, not us, our API is, our technology is intelligent enough to know when we have enough sample. And we're extracting features constantly in a streaming mode. So when we have enough sample, it's already been extracted, it's passed through the algorithm, and the results come back in milliseconds. And so this is all happening in streaming real time for the doctor. So if you're doing screenings on 50-year-olds in your hospital, it might be for cognitive health to identify early stage MCI. It might be for MS. MS can start as early as high school, even earlier maybe, but it's often not recognized until mid-20s. I have a good friend that he was first recognized at 28. He was having a lot of vertigo, and they finally did an MRI on with him, and he had a lot of lesions on his brain. And they pulled him out and they said, when do you tell us about any kind of symptoms, headaches, migraines, anything? Did you ever pass out? Did you ever do this? Did you play football? So on and so forth. And they traced his MS start back to junior year in high school. And he was now 28 or 29 years old before it got diagnosed. We're working with Intermountain Healthcare to produce an MS model that would identify that on a screening. Inexpensively, we're talking dollars, a few dollars to identify it. If you saw a screening that said there's a potential it's there, that's giving you the tool in the toolbox. It's giving you an indication you should consider a referral, So that the whole goal is to identify early, to treat earlier, to try to shift to preventative medicine. In the ADHD and the autism, we're building this model and we're building a version to be at home with the parents, because the triggers that occur in autistic children don't often occur in the office. They occur in their real life environment. To identify what those triggers are can help a parent help a child avoid those triggers and have a more normal life, Identify them early also before their brains are developed past a point of treatment. can help ensure a better outcome, or at least increase the opportunity for a better outcome by identifying earlier. I always tell people that you don't need a tool, sadly, to tell that someone has advanced Alzheimer's disease. What you need is to know as early as possible and to support clinical teams with that information so they can make clinical decisions about it. Okay. So that's kind of how we think.
It's it is definitely non-invasive because all the tests and everything is way different, how it's detected even. So it's very much then scalable in that way because it's just a sampling of voice. But so this is a big unlock in terms of access, equity, and early detection. Huge unlock, right? Like this is like, and so in your world at the moment, what is like who are the clients at the moment? I know, you mentioned several use cases, but what type of clients exist? Is it like the hospitals specific in special treatment types? Could you walk through us that? And also who are the potential that you probably opening the doors now or next 12 to 24 months?
Sure. So the primary users right now are clinics and hospitals, in behavioral health and in cognitive health. Those are the primary users. We have one of the larger institutions in the U.S. Is working with us to launch a progressive neurological disease model, and we have a number of those already completed, so that they could generally test for that across the population, just as like we would do a blood test, and you have like 60 things in your blood test. Well, you could do a voice test and have 12 in it right now, and in a year it's going to be 15, and then maybe 25 a year after that. So you could look at different things and be screening people. The cost to doing that is minutely small compared to other types of way of doing this, and it's screening. So you understand what the efficacy of it is. It's been built with peer review in clinical environments. We do applications in Europe, for instance, where callers are being qualified for consumer protection reasons, being qualified whether or not they're at risk to buy a certain product, whether it's insurance or it's a financial product or whatever. And in those cases, we give a green light or a red light. If we detect a deficit, like anxiety, depression, mild cognitive impairment, something like that, that would require special treatment, we give them a red light and they refer the person to a specialist. So there are those type of applications in places like Japan where they have, and other places where they have truly national healthcare systems. They do annual healthcare assessments to qualify what are our needs going to be 12 months looking forward. We're parts of that. When they call and they're interviewing patients, we're listening to that and we're doing a battery of tests for them. Anxiety, depression, mild cognitive impairment, different neurological diseases. And they get, and the person they're calling knows it, but they're calling 600,000 people in the population to get a broad group of them to plan for their healthcare budgets. By taking that burden away and putting that all in a 40-second call, 40 seconds of the call, we're shortening that call by about 15 minutes. And they get to spend more time with the person talking about their real life needs and planning for that. So we do those types of things. Renewal for driver's licenses, where individuals have to take a cognitive exam. They're doing it on paper right now. They have to go to a facility to do it and have it administered. We have a pilot where they're doing it by voice over the phone. So they're getting their license renewal. If they're 70 and older, they're getting their license renewal. Part of that is a cognitive test. There are certain nations that require that. So those are the types of things that we do get engaged in. I think in the future, we're going to see the expansion of more models and the expansion of more languages. We're adding Dutch and we're adding Arabic right now. We're working with Cleveland Clinic in Abu Dhabi. And we're doing some pharmaceutical work as well, where we're parts of the pharmaceutical clinical trials. Those are the types of things we're doing. I think the future really relates to access. Individuals, regardless of where they're born, by chance of where they happen to be born in the world, still deserve to have high quality healthcare. And if you can connect information to clinical teams, regardless of where the two are living, and have a meaningful interaction, video conferencing with actual actionable data, objective information about the patient. And part of that will be vocal, part of it will be facial recognition, part of it will be whatever it is, the weight, their temperature, so on and so forth. I think that we could improve the reach of healthcare across different populations. And that's our goal. And that's where I see the future going.
How much is I'm assuming it's already, from the few things you mentioned, you already have a global clientele outside of the US. How much is your customer base looks like US versus non-US, or US versus Europe versus Asia?
So we started in the US. We're in Canada. We're in South America now. Our second market was really Japan. There were multiple reasons for it. It's the oldest population on the planet. There's an interest on their part to find tools, particularly AI tools, to help augment the delivery of services, the identification of illness and disease, the management of populations. All of that's taken very seriously by the Japanese. And so all of those reasons combined, it was our second language. Our third language was Spanish. English was across all English languages, Australia. I shouldn't say that. We're not in Scotland yet. But Australia, Ireland, Britain, Canada, and the US. So we reach, English reaches and has been validated in all normal, in those normal, what we see as speaking English countries. And then Spanish in South America and in the US. We'll add Dutch and we'll add Arabic, and then we're adding French and German this year. So.
Wow. Yeah. To me, it looks like, wow, no brainer, right? Like this should be everywhere, right? But still, I want to ask you, what's been the biggest challenges, especially getting providers and health system to adopt, vocal biomarkers into their clinical decision making? Was it the trust, workflow, reimbursement, or something else? Because you're also dealing with global clients. So could you shed some light on that?
So, after Jeff created the natural language processing tools, a number of institutions, very smart people at universities and university hospitals, began to try to adopt the analysis of words to certain languages. There was some modest success and a lot of papers written about Agatha Christie's novels. She died with Alzheimer's. They could track backwards, 25 years to when she got it, or 10 years earlier, 40 years of novels. Most of us don't have 40 years of novels to go into a clinic with. And so, it's an impractical, it's a nice academic approach. It definitely demonstrated that language was associated with disease. We know that. There's what's called a Parkinson's draw, and in Parkinson's, their language gets longer. Their vocal cord musculature suffers from the disease. 9 years ago, there was, like the wow moment that we have when we talk about it. The wow was more of a disbelief. People now believe it. So some of the early attempts to adopt it were not successful. Their approach was word-based rather than being vocal biomarker-based. And so when you shift to vocal biomarkers, you get this richness of information and data. 15 million data elements, 2,548 different elements every 10 milliseconds is, in a minute you get about 110 words. Syllables, maybe you could say there's 220, there's not that many, but then spaces and other things. You might have a 500 element data set. Machine learning doesn't like that. Machine learning wants millions of data elements in order to do its job. So you match the data set with the tool set that you're working with, and that magic happens. Accuracies go up. During the pandemic, another big element was that there was a real push to open up reimbursement for non-contact and remote monitoring of patients. That included voice analysis. Even though voice analysis didn't exist, somehow they got it in there. The other thing that happened 2 years ago was we created ambient listening and streaming capabilities, which allowed us to do everything we were doing in real time. So now you had multiple models validated by clinical groups in different parts of the world and papered, academic papered. And you had a reimbursement strategy, and you could do this without interfering with the interaction between the doctor and the patient. So those three things came together to make this a real practical tool, a real practical solution for the clinical environment. You're not imposing on it. You're simply adding more information. And you're doing it with one of the most natural data collection sets we have, which is speaking, and voice and the creation of speech is the most complex motor function we have in the body. It's connected to so many things. I mean, it's self-conscious, so it makes the data objective. We're not consciously thinking of what we're going to say. And then the other thing that happens is it engages the lungs and the vocal cords and the tongue and the cheeks and all kinds of things. And in order to create speech, the orchestra has many instruments in it to create speech. And because of that, when there's damage in the central nervous system, one or more of those instruments is affected. And the brain is so wonderful that the first thing it does is try to keep speech normal. But it's taking a different path to do that because there's a roadblock somewhere. We can detect that roadblock. That's what we're detecting. And that roadblock might be Parkinson's early stage. It might be Huntington's pre-manifest type of thing. So all of that is what allows us to create this. And then those three factors that there was accuracy, non-intrusive nature of this, non-invasive, non-intrusive nature of it, streaming capability, CPT code reimbursement, all of that came together in a perfect storm to allow people to integrate it into their workflow. Okay.
You have this company for many years, not recent. And now I feel like there has been tremendous advancement in terms of AI and just in general. Have you seen the acceleration on your side, especially, at the end, this is AI is a brilliant data analysis machine, and that's the best part of it, because that's where is the biggest value is, because just humanly we will take so much more time, right? So how would you say, have you seen that acceleration in advancing in analysis, either in terms of efficiency or accuracy, that you have seen on your tech improving, especially for voice analysis?
Yeah, absolutely. Not just in AI, which is critical. The speed of computing is critical to what we do. The capacity to be able to do this in near real time couldn't have happened 10 years ago. Just we weren't capable of it. The acceptance of AI in healthcare, not just the acceptance, but the excitement about it to augment the hands of the individuals, which are always going to be limited, at the force multiplier concept. All of those things have come together to allow us to deliver a product at the right time in the right space, for individuals to provide better service, actionable information, make better decisions and better referrals, act upon, take it home with people, do it in video conferencing. So you could actually have a virtual environment with a doctor that's augmented by actual data. And a doctor can, they're disconnected to some degree, and all of a sudden they know what the person's anxiety and depression is because it's streaming on their screen, and they have a chance to ask the next question could be slightly different, It may not be that your depression is sky high. It might be what's been going on in your life since the last time we spoke, and your son is in soccer. Is that going okay? That kind of thing. Become more human in our interactions with individuals and exploring where they are with their health. So That's what I think AI is going to provide us.
Are there any, I mean, I'm sure there may be, are there any competitors in the field you are saying upcoming after this, or it's still more of a green field right now? Where do you see that? What's the competitive landscape?
So in vocal biomarker analysis, we had the opportunity not to be even though 9 years ago we were a startup, we had a team of individuals that had built the first in speech and language multiple times. And so we were engaging and building the first. We happened to apply for patents early so that we have certain patent and IP protection internationally as well as locally. I mean, in the US. When you think about the density of information, the genome provides a very, very dense piece of information, but it's forward looking. So if I have certain genes that would, or certain alleles in my genome that would indicate that I could have a certain disease in the future, it doesn't say I have that disease. It says I have a certain propensity or likelihood for that disease. And the density of what we are looking at, 15 plus million data elements every minute, diverse information, is second only to the genome in density. It's very, very dense information from a medical standpoint. And it's different than a genome. It tells the doctor what the person has at the moment they're with them. They have elevated depression, or they have Huntington's, or they have Parkinson's, or they have MS. It tells the doctor something that the genome can give them information about something potentially happening, but not the absolute of it being there. So those are two different types of information. They're both very, very valuable. In the future, we're also going to see, facial analysis and eye analysis are things that can provide information. And we're working right now with a number of companies for AI intelligent patient rooms, where they're observing a patient and their movement in the room and risk analysis and things like that. We're becoming parts of those systems, so that while the patient and the doctor, or the family member and the patient are talking, we're doing analysis on the patient selectively. So next time the doctor comes in, they have a range of analysis already done on them, from their normal day, from how they've been interacting and living. Facial analysis may come into play there, where they're looking at elements of the face. The face is not as dense a piece of information as voice is. Eyes are not as dense a piece of information, but they can augment information and provide information themselves. So we're going to see the advancement of that kind of technology, because infrared could actually tell the temperature without someone actually trying to measure it. We do that already with a handheld one. We could do that with one from, it knows where the person is. It can do the same thing a nurse would do, and then have that information waiting for the nurse. The nurse doesn't have to take the time to do it or carry the instrument to do it with. So we're going to see these rooms not just be intelligent, but also operational, have functionality that's going to augment the quality of care. That's all going to, it's already there, and the capacity and capability of doing it. So Canary Speech creates algorithms that we run on the web. Those algorithms can be deployed in the room of the hospital. We don't have to go to the web with the information. We could do it 24/7 in the room. So we're deploying that way also. So imagine that you're trying to monitor someone 24/7, and 95% of our cost is going back and forth to the web. All of a sudden, you've made that more practical from a cost standpoint, because I have a fraction of the cost to do the job. So these are things that I think I'm so excited about. The biggest one I'm excited about is that you could reach anyone in the world. You can eliminate the bias of where a person just by chance happened to be born. That's the thing I'm most excited about. Healthcare should be available. And we are, in general, people who care about people. Not just Henry O'Connell, but people care about people. They do in general. They're limited by what they can accomplish and do. And we're moving into an era of our development as a as a world where these things can become practical. We can use AI will help us be better at everything and be better at being responsible, I think, too. That's my thought.
So really, I guess what's headed in the future for for your company or Canary Speech is you are not just going to be limited to the vocal analysis. There is things you will augment to
Mhm.
do, and those can be anything in terms of from motion to facial, whatever, all those things together. Core still being the vocal analysis, just because it's most efficient in identifying all those things that it gives us, and then augment whatever you can and make it more comprehensive, more accurate, more filled with information. That's kind of where you're headed.
Mhm. Correct.
Okay. But this definitely comes from more partnerships, right? Because that's going to be the core of growing something. You probably won't build all those things.
No, you
Uh,
won't. And
so
many of them exist. And we work with partners in different parts of the world right now that are excellent at facial analysis, and working with a couple of them to blend what we do and what they do in a practical way. You have to find a practical way for it to be deployed. It has to not interfere with the normal flow of work, the normal flow of interaction between a clinical team member and a patient. You want to just be fluid with that. So the information is there without detracting from the relationship.
yeah, this is the key. I just want to double click on this last point that you said. A lot of people who are listening to this shows, and a lot of health tech founders listen to this, a lot of venture capital listen to this. And one thing I want to say it from my experience too, that uh, try to be in the flow without changing it for them, or being really like not be like a extra step in there. And once you do that, it loses the value, kind of. That's what it is. And so I really like that. And what do you think about the AI scribe companies? Are you partnering with them? I feel like that looks like a easy way. They are already listening to the conversations in all the rooms there. And any good conversations going on that end?
Sure. The at HIMSS about 6 months ago, we showed in private preview, and we have since shown to over 180 hospitals an interaction with the Dragon Copilot dictation platform and Canary Speech functioning seamlessly. So just if you have the Dragon Copilot in your hand, you have Canary Speech also. And so we're just seamlessly there, and on the screen will pop up a clinical decision support message indicating that a referral for behavioral health might be necessary with elevated anxiety, or elevated depression detected. And that's seamless. It's totally seamless. That's already something that can be demoed and is available for people to see. It is commercially available first in August, and then September and October. We'll be at HLTH, So there is that's a significant partnership. We've been working with the people at Microsoft within their systems, in their platform, in their AI platforms. We've been working with them for over a year, just perfecting this. So I'm excited about it. I think it's going to be a wonderful opportunity for us to enhance healthcare.
Yeah. Well, great. Well, this has been great. Thank you so much for sharing all the insights. And before we end today's conversation, I like to go into a quick fire personal round.
Mhm.
And what comes to your mind, just go with that. And let me start with that first. So, what's one book or idea that reshaped how you think about innovation?
I think when I was young, I read a lot of Kurt Vonnegut, sci-fi author, and I know this is silly, but uh, it it provided me with the opportunity to be a dreamer. I would read Kurt Vonnegut and I would think, oh my golly, will ever will ever any of this be possible, you know? And we're living the possible now. We really are, you know? So that was my big, as a child, it kind of steered me to science, frankly.
Yeah, I always say that to this, that eh, it's the emotion and the feeling, right? That's what
Yeah.
uh,
I said,
makes you
yeah,
makes you to the next level, right? It gave you that, and that made you question or think the view. So love that. Okay, cool. What's been your most meaningful moment at Canary Speech so far?
we are fortunate that, and every CEO should say this. Every CEO starter should say this. We truly have just an incredible group of people that we work with, and they work so hard. And a lot of what we are doing has simply never been done before. And I told our staff a story that I heard once, and I try to live my life this way. I said, I heard a story of a horse pull once years ago. And this horse pull was 6 horses pulling an unbelievably heavy weight. And unless all 6 horses hit their yokes, just one pull, the weight would not move. And I said, the same is true of a startup. We have to be equally yoked. We have to be looking forward to the same vision, not a similar vision, the same vision. And just because it appears impossible, it's just going to take us a little longer. And if we're equally yoked, pulling that seemingly impossible weight, it'll occur. And I said, I promise you that if you look to your right, you will find me yoked with you. And one of the greatest joys I have in being in this company is when I look to the left, I see you there too.
I love that. I had someone else, a founder who's also building another company. He gave me that example when I asked him, "What's your biggest challenge?" He says that I view my team as the crew who's rowing. We got to make sure everyone is in same direction. If we are doing that, that's fine. That's it. That's my job done. That's what it is. So it goes in that exact way of, everybody needs to believe in the same way, not the similar, exact vision. So, and that's what it is. So nicely put. What excites you most about the future of speech as a diagnostic tool?
I think we're at the very beginning is what is exciting to me. We've got 12 different validated models in different languages, and I know we're at the very, very start. I think that we have the opportunity to develop a series of childhood illnesses that I think can change the nature of how our children are diagnosed, and certainly how the diagnosis is augmented, I think we can elevate the already excellent team of clinicians that we have. I think we can help elevate them with AI tools, and Canary Speech is an AI tool. So the excitement for me is the reach, both in the number of languages, the number of diseases that have been qualified and validated, the number of populations and communities that we can serve. That's the excitement to me, the reach.
Right. On that note, we will end this conversation. Thanks for sharing. I'm actually pleasantly surprised because before this conversation, I didn't think exactly how this works. I knew a bit what I knew it, but after this conversation, I'm just like, wow, this needs to be everywhere, right? And more people needs to know, and this will be going everywhere. I know that because this just makes sense. This is one of those things, and so really excited to have you today. Thanks for sharing it. Where can people find you if they want to get in touch with you?
So all of our emails are simple. If they want to get a hold of me personally, it's henry@canaryspeech.com. Our website is informative, and it has contact information. It's www.canaryspeech.com. So those are practical ways of getting a hold of us. I do answer emails, and if you go to our webpage and you ask for any information, you will get a response. We love that kind of thing coming in.
All right. And we will make sure wherever you get this show, the email, the website links will be there in the show notes. And Henry, once again, thanks for taking the time and sharing what you are building. And all I can say is this is going to be really, really significant and big. It's just a matter of time. That's what it is. That's how I see it. And thanks for sharing your journey, also your personal journey a bit of here. Thank you so much.
Thank you very much.